can't see it. लाइफ कुछ दिखा तो रहा आगे
Hello. Is everyone joined the session? आवाज आ रहा है? Okay, so my name is Sujit Pandey. I'm working in Infosys as a senior software engineer in the data analytics team. And here we are giving our session on big data analytics. So what is actually a big data analytics is? So basically what we know from big data is like when we say like when data is becoming a big data. So this term is get famous in last couple of years. So every applications is based on big data analytics. So and it's solves lots of problem of day-to-day life, since we know today like we have a Twitter, Facebook, and many social media platforms from where we are getting lots of data every day, and every seconds they are generating a huge number of data. So why big data come into picture? So the reason behind this is that the way data is coming to us, so our traditional systems become inaccurate or incapable of maintaining all this data and processing all this data. So big data come as a solution for this kind of problem. And here we go with our slides. So, what is big data? So, whenever we say big data, so it's not only like when your system is not able to process the data or store the data, then it becomes a big data. It's never happens like that. So, the main concept of big data is that when it satisfy all the 5 V's here, V for volume, variety, velocity, veracity, and etc. So when the data have such kind of characteristics and properties, then only we can say it's big data. So as you can see in the slide, there are 4 V's here. So first one is your volume, the size of the data which is coming to us. So this is one of the parameter on which we can say whether a data is a big data or not. Second one is your variety. Variety means it may come in different forms. Like we know earlier in RDBMS, we have only structured data. But nowadays, like videos are there, emojis are there, images are there. So these data are not structured. These are all unstructured data. So variety is the second parameter which decides a data is big or not. And the third one is the velocity, through which like at what speed the data is coming. Say for example, if your data is if social media data is coming per seconds, like in per seconds there are many tweets are coming, many comments, posts, videos uploading YouTube, for example, you can say. So these are the velocity, the speed at which the data is coming. And the third one is the veracity, that is the various level of data uncertainty and reliability. That means you never know the source from where the data is coming, whether it is coming in a structured way, unstructured way, or semi-structured way. So let's first know what is structured data and unstructured data. So structured data, for if I'm going to give you an example of structured data. So structured data is the RDBMS data, like in MySQL data. All are structured, like both have relational database model. We say it's a relational database model where each row have some relationship with the column. So suppose name, age, salary for an employee table. So their name, we know it's all comes in a structured way. Like you can see by viewing the database, you can see that you can say, okay, this is the set of data. You have the understanding of the data, okay, what data is telling you. But when it comes to unstructured data, so suppose if I post something on Facebook, So those data, if you are looking into your database, so you can't have insights or knowledge like what kind of data it is and what it is trying to say, because it has no mapping and all. So for that reason, a new concept come into the market called NoSQL, which means not only SQL, because SQL is a traditional database which is basically built for transactional data, structured data, not for unstructured data. So, for example, a couple of NoSQL databases are like MongoDB or Cassandra. We'll not go on this topic much because this is not a part of the session. So, big data is nothing but when all these five V's satisfy some, when data satisfy all these five V's, then we can say the data is a big data. Now, then our next question will be like how to deal with this data. Like, actually, we are not doing anything here. Like, many people say, like, big data is a different technology. It has different concept. It is something else. So it's nothing like that. We are also dealing with the same kind of thing. Like, our main goal will be like converting or transforming the unstructured data to the structured data, because the final output which we are expecting is like from the data we should have the knowledge or the insights, like what data is about. So structured data. So here our task will be the big data. What it will do, it will convert your unstructured data into some structured way, like so that you can have an idea of what is data is about. Let me share one test scenario here. So suppose your data is coming from Twitter, Facebook, LinkedIn, YouTube, for example, and you are consuming the data. But the data which is coming from all these different sources, when it will come and store into your databases, so you have no idea like which post is coming from which source and which is coming from which source. So this is kind of classifications. Like if I'm consuming data of Facebook, then I should know, okay, the data is coming from the Facebook, not and nowhere else. So all this comes in the single frame called big data. So so the next slide. So suppose so now like Hadoop. Hadoop is the first tool come into the picture which solve the problem of big data. So earlier, like mainly processing data in from MySQL, like writing simple SQL queries, doing some aggregation is very simple, because the data is structured way, so we don't have to do much. So but when this unstructured data starts coming with a great velocity, so that time we are mainly concerned with the two things, like the storage of this kind of data and the processing at the faster means at a very fast way, because the data is keep coming from the sources, because they are coming at a very great velocity, and we have to deal with that. We have to consume the data very faster. So Google have come up with an idea called Bigtable, which was also based on the problem of big data, um, uh, converting and transforming your data, unstructured data in a structured way. So, but Bigtable has some disadvantages. So one of the employee of this Google, he have an idea. He got an idea and he got the solution, and he come up with the same concept. On the basis of the same concept of Bigtable, he come up with Hadoop. And the name of Hadoop is given because he got the idea when his kid was playing with his toy, and the name of his toy was Hadoop. So this is the history behind naming Hadoop, how Hadoop come into existence. So Hadoop basically composed of two components, which is the main two problems. One is storage and another one is processing. So for storage, they are using HDFS, Hadoop Distributed File System, and for processing, they are using MapReduce. We'll come in detail like what is MapReduce and what is HDFS and what is the architecture of HDFS and how it is solving our problem. So first come with HDFS. So HDFS is Hadoop distributed file system. The concept of this is normally a file system like our hard disk has. It's an external hard disk, nothing else. It's just for storage. It's not doing any other task like any processing and all. It's normally a kind of file system where we are storing our data. Since the data is coming very fast, so your single system, you can't store all your data, all this huge data in a single machine. So that is why distributed file system concept comes here. So here what we are doing, we are distributing our storage in multiple machines, and that is what when when a group of machines get connected to each other, it is called as cluster. Cluster is nothing but a group of when we say a society means a group of people living together or living in a same network or in the same um, you can say in the same society and all. So that is called society. So it's the same concept with um, distributed file system as well. Because the data when coming, so when we are thinking of dealing with all this kind of data, so the main concern of storing data is that our data should not get lost anywhere, because when we are consuming the data and if we face a data loss issue, then it's no use to process the data on like few data are missing and few data are there, so there is no way of there is nothing to do with such kind of thing. So so the first goal is to make our data stable, consistent everywhere, so that if no data get lost anywhere. So what HDFS architecture does, it has some one replication is a term which is nothing but a backup or a copy of a data. Like when our system is connected with in a cluster, so the data which is coming in one system, that is so might be that machine in which I am storing the data, it might get crashed anytime. So but if it get crashed, then I will lose the data. So what HDFS does, it keeps the copy of each data and split it into and distribute it to the other network machines, so that if one machine fails also, we don't need to worry about the data loss, because that data will have be stored somewhere else, and that is called replication factor. So replication factor is nothing but how many copy you want. When you go for a Xerox machine, and so you say like I need a 3 copy or 4 copies, something like that. So here also replication factor is same thing, where you can where you have to say how much copy you want. So by default, HDFS has a 3 replication factor, like 3 copy. So if your machine crash or failed also, you don't need to worry, because the 2 copies is still backed up in your in the system. The second thing is that data recovery and like how to so now our data is not getting lost, so this is fine. But the next problem is that when we are processing this huge data, so we don't want to much time. We don't want to spend lots of time processing huge data. Say suppose, for example, I have a 1 GB of data and your hard disk capacity is 500 MB, and you want to process it. So you can't process the data on your system. One option will be there, like you have to distribute the data, like you have to divide the 1 GB data into small chunks, and one by one sequentially you have to process it. So the same concept HDFS is also come up with. So what it does, when your data is coming huge, so it actually dividing the data into multiple numbers and assign those data to Hadoop. So Hadoop is a framework. It is basically called a data processing framework, where your data get splitted and distributed on number of systems, and at the same time they are performing the processing. Like if 5 machines are performing the same task, so your 1 GB data will be finished in the same time. Like it's not like not like sequentially it will get and process one by one, because that will be time consuming one. So, because the data is keep coming and we can't like 1 GB data is coming now, tomorrow it may be 10 GB, day after tomorrow it may be 100 GB TV, something like that. So basically it is distributed the your data on all your machines. And say suppose you have a 3 node machine, or you can say 3 node cluster. Here node means your laptops or commodity hardware, laptops or your machines or your servers. So where all these 3 are connected to each other. So now we are going to assign one of the machine as a master machine and the rest of the machine as a slave machine, or you can say worker machine. So the when master so master will do nothing. It has to do nothing because it is the master. So worker will have to listen to the master or the supervisor. So here the task of the master is to assign tasks to the workers. For example, when the data is coming, the master's task is to divide the data and split it or distribute among the workers depending on their strength. So suppose if one machine is 500 MB, then it is not going to give that machine more than 500 MB. And some machine may be 1 GB, 2 GB, sorry, 200, 1 TB capacity of machine. So there they can split, they can give more tasks to them rather than the small machine. So here few terms are there which are get involved in all this Hadoop, HDFS and MapReduce. So the first thing is the name node. Name node is the heartbeat, or you can say the heart of the Hadoop ecosystem, because name node is the master node which is having the metadata of all the data that is coming to Hadoop or that is getting processed through Hadoop ecosystem. So name node get the metadata, and after that another master master node is there called job tracker. So the job tracker task is nothing but to assign the task to the slaves or the slave machines. So job tracker will assign the task, and it will keep the state, like whom he have assigned how much of data or how much of work, so that if someone fails, if some say suppose if some slave machine get crashed or fail also, then we don't need to worry about that whether our data will not get processed there. So job tracker will take care of that. So if any machines fails, or if any worker unable to complete his work, so job tracker is going to take the work from that machine, and it going to assign that task to other machine which is idle or which is doing nothing or which have finished their work. So it is very simple. Try to relate with your real world example. Say suppose I am a teacher, so I am a master now, and you all of you are like my students. So you are the slaves or you are the workers whom I am going to assign the task, and you are going to finish it in the given deadlines. Like in engineering we have completed lots of assignments and we have some deadlines, like before this time you have to complete this assignment. So that is a task which each people or individual task we need to perform there. So for example, I am going to give you an example. In a class, a teacher asked his students to find the name Ram in chapter 1, which is consisting of 4 papers, 4 pages, and give me the number of times the Ram is repeated in all these 4 numbers. So what people will do? If each and every one reads the whole page, 4 page, and for reading the whole page, all those chapter 1, it takes 10 minutes or 15 minutes time. So now each one is, so how can we um, give the result within less than 15 minutes? So what I'll do, first approach will be like everyone will read from there, and from their end, and at the end they will say suppose first student say it is come for 20 times, someone says 40 times, someone says 30 times, and based on their votings we'll say okay, most of the people are saying 20 times, so it will be like 20 times. That's it. Second one, what I'll do, I'll ask two students to focus only on the first page, others on the second page, and rest are on the different pages, and only get me the count for that page only. So what I'll do, I'll assign this task to 5 students, each of them at the same time they started the task, and within a minute I will get the time, I'll get the output, like how much time Ram is repeated or mentioned in these chapters or in this book. So here, like earlier, our earlier approach was like not efficient, because it is taking 15 minutes to get the result or to give the output. So our processing is very slow here. But in this approach, my output is coming within a very small period of time and in a very fast way and with accuracy, because each individual will not going to make a mistake, because they don't have to process the whole chapter, they have to process only a single page, and from there he have to just count the number of times Ram appeared there. So the same concept comes in Hadoop, which is in big data, when we are learning some program, Python, Java, whatever, there our first program is hello world program. So in Hadoop, the hello world program is our word count program or word count task. So the word count is like you have a data sets or you have a text file, and I need to know which word is count, means comes how many times. So this is called word count, each word. So here the concept of MapReduce comes. So let's now talk on MapReduce, because HDFS, it's a Hadoop distribution. It's for storage purpose, and how it store the data and how it assure the data consistency and all. So the MapReduce. So here MapReduce is a sequential term. Reduce can't be happen without map, and map is the first thing which have to be done. So in MapReduce, so the concept of MapReduce is when your data is coming. So say suppose I'm explaining MapReduce concept with the help of a word count example. So say suppose I have a text file containing my name or something like some data are there, and I need to know which word is coming how many times. So what I will do, what is the approach will be, what will be our approaches. So we're going to first split the data or split our text file based on some delimiter like you can say comma separated, TSV, because we have different kinds of formats here. We have XML, the data might be XML, the data might be text, the data might be a DB data, the data might be a CSV, TSV, JSON, anything. So say suppose we are going to split our data or our text on the basis of a space, normal space. So mapping is so this is the task of mapping only. Mapping ends here. Mapping does nothing, only it will split the data on the basis of a delimiter, so that your each data individually get splitted. Now reduce come into action. So the input of the reduce is the output of the mapper. So in MapReduce frame program job, we have two things. One is mapper and one is reducer. Earlier, only Java language supporting this MapReduce framework, but now every language can do MapReduce. So one we have mapper and one we have just split the data on the basis of the space, and this output it will going to send to reducer, so that reducer can start doing its task. So here mapper, you can say it's a master which is assigning the task to the reducers. Reducers are like workers and slaves. So each reducer will be like, there are multiple number of reducers. So each reducer will get a specific block of text, or not all the whole text, a small block of text. So suppose 2 or 3 lines. So this reducer's task is to just count the number of times each word is appeared here. And like that, all the other reducers will also do the same thing. All the reducers also process the data and give the output individually. Now, after this task is done, the reducer will combine. We can say split and combine model of map reduce. First, it splits the data, then it's combine the data as a single output. So after each reducer are done with their work, so they are now going to combine all their results or output in a single means like aggregating everyone and combining everyone in a single text file. So that output text file will contain each word corresponding to their number of counts, which we have also implemented in Java using hash map. Like the word will be your key and the count will be your value. Simple. So this is the concept of map reduce. So it is mapping and reducing, nothing. So mapper will become the master and reducer will become the worker here. Okay. So here HDFS and MapReduce. So this is the main two hard component of Hadoop ecosystem. As we have discussed, HDFS is for storage and MapReduce is for processing our data. If you have any kind of questions, or if anything is not get cleared, so you can ping me on the WhatsApp group or on the chat box, so that I can, because we are moving now to the next level. So if any doubt is there, then we can give you the I can tell you I can clear your doubts. So if you have any doubts, I'm muting for 5 minutes. So anybody have any kind of doubts can share their doubts with me, so that I can solve their problems or solve their issues. Okay, so I got one question. I got a question from Simon, which is asking me like, what are the reference books or any site we can refer to begin learning big data? So first of all, I would like to make it clear, because as a beginner, I have not taken any courses or any books or something like that, because the main problem with such kind of things is that you get lost somewhere else, you, because you don't know what is the roadmap of learning this kind of technology, since these are the very new technology. So many of the um, um, you can say corporate level persons, so they are taking the advantages of this, because it's not a very tough thing, it's not something rocket science, it's basic things which we have met earlier, but they are giving it in a new shape. So that is, so first of all, never ever try some courses, mainly any courses which is online, because my experience, it is my point of view, might be yours is, and at the end I will give you some references as well. When you are going to some videos, so basically they are already those videos, you are not much interactive, uh, because you are purchasing that video and that's it. So all you have to do like self learning, and they are not much clear also, because they are giving you some kind of technical terms which is not even understand by a normal person. So suppose if someone is brilliant, then for that kind of audience it's good, but for me, my audiences may be a beginner, maybe a different field, or maybe some different kind of, not from that background. So first thing is that if you take any books or references or any courses online, so they are they are not providing you the roadmap. So roadmap is nothing but a direction in which you need to learn, because there are lots of blogs you will find for big data, lots of books there are in the market for big data, Hadoop and all, and those are they are not giving you actual concept of big data. Actually you find yourself lost after purchasing the course or something like that. So first of all, self learning is the best thing, which I uh, telling you from my experience. I In 2015 I have no idea what is big data is, and only I know is Java, that's it. And what is big data, what is Hadoop, what is all these technical terms, I have no idea. And that time many people are taking courses online, paying 1 lakh rupees, 1 and 50 lakh rupees, 70,000 for this. And I have not that much money, so I can't afford that. So I started learning by myself, and I also got deviated. Like I also not get, because I am also following all these blogs and reference books and all these YouTube videos and all. So I don't know like how to what is the structured way. Like when we design some program, we have some data flow. Like okay, first we have to do this, then this, then this, then this, like that in a flow. Then only we can learn anything. But there are like it's a kind of open ocean. You go to make a dive, go dive into it, and you'll find yourself lost somewhere at some point. Like start when you start, find it good, okay, I'm learning, but in between you find yourself lost, like you will not be clear about what the concept actually is about. So basically stop avoid taking courses online first, uh, and mostly those which are taking lots of money, because I don't think this course is because normally when we are doing Java training and all, they are taking us 10K, 15K. So it is also not something next level that we need to pay more than 50K or 1 lakh, something like that. So basically, it is all your self learning. You need to know what actually big data is, and never go through the book examples. Try to um, visualize all these things with your real life examples, real life problems with yourself, because the concept is not new here, it's already present there, and there's just a new wrapper is come up on this thing, and it is called big data and analytics. It's a big name. So instead of going to book, you can mainly go with some consultant or some experienced person, because I also did the same thing. I took some guidance from my experienced colleagues, and they have guided me in a way, and they have given me a clear picture of big data. And I think that helps me to understand it better and to become a good, not expert, but yeah, I have a good understanding, and I know right now I don't feel lost or something like when someone asks me what is big data, and I can explain them. So basically focus on yourself, whatever you will learn. And my main goal is that I don't want to give you any course or any kind of tutorial or number of slides, huge number of slides, and keep engaging you in there. For me, it's like to show you a path, and this path you have to follow, and you can learn yourself, because at the end of the day it is you only which is going to achieve it. No one can make you understand. It's your understanding. So better focus on yourself. If you are not getting, take references from the sources or blogs, but don't rely on them or don't depend on them much. Otherwise you can't learn very easily. Okay, so another is, what is split and HDFS block? Okay, so split and HDFS block is, so when you are storing the data in a hard disk, so suppose I'm not talking about Hadoop and HDFS right now. Forget about Hadoop and HDFS. Normally your hard disk, or when you have an idea of our operating systems, so there we have a concept called blocks and partitions. So generally here split means partitions. You are partitioning something, and HDFS blocks is like a block. It's a memory. Like so block is nothing but that a block or a space where you are storing your data. So in HDFS, by default, each block is consist of 64 MB. So it's a very good question, and I'll give you an example to explain it better way. Say suppose you have a 10 number of blocks, and each block have a capacity of 64 MB. Now I need to process the data of 512 MB. So what it will does, it will divide the data 512 MB by 64, because each block have capacity of 64 MB. So suppose it divided by 65. So mainly you need only 4 blocks to execute or to store your data. And the very good thing of HDFS is that, say suppose like in array, I'm giving example with an array, static array. So static array is like you assign some memory, say suppose for integer you are giving 10 number of blocks to be used in array, but sometimes you are not using 10 blocks, you are using 3 blocks and 4 blocks, and the rest of the blocks get wasted. So in the HDFS, if your data is 32 MB and your block size is 64 MB, then that 64 MB is not going to be used or not going to be wasted. 32 MB data will be stored there, and the rest of the 32 MB data will be also be get used from somewhere else. For small data, obviously we are not going to use big data, because for small data it is not there. But HDFS blocks are nothing but a space which is of 64 MB of size, and that where we are storing our data. And all this number of blocks, when combined to each other, it becomes a hard drive, or you can say file system. Okay. Is there any software of Hadoop to store our data? HDFS, obviously. It's not a software, it's a framework, you can say, or you can say storage purpose. So mainly Hadoop is composed of only 2 things: no third-party software, nothing here, because Hadoop is open source, and mainly two things are there: HDFS and MapReduce. Hadoop has its own storage system. That's it, nothing else. They don't. If you don't want to use HDFS, it's not like you can't use big data. You can replace that HDFS with your external hard disk or your machine hard drive, but that need to be configured. But that need to be configured by yourself, because you are not using HDFS, because HDFS is the inbuilt storage system that comes with Hadoop. Retrieval of data efficient from Hadoop softwares? Yes, it is, because when you are retrieving the data, so it depends. Actually, retrieving data, it's not retrieval of data is not a new thing here. Earlier also we are retrieving data. There is a course called information retrieval. So, but that depends on your requirement, like what kind of data you are retrieving. If you are normally retrieving structured data, then I don't think you need to work with Hadoop or HDFS, because special purpose. When your data is unstructured and coming at a very high speed, then only you need. That's what I told you. Like big data is not like any data can become a big data. Big data only can be used when it supports all the 5 V's what we talked in our first slide. So it depends. So it's your decision. It's your you know um, decision whether whether our data is um, that much big or not, whether we have to use Hadoop or not. Like it's not fancy, like whatever you need, you just need to process through HDFS. Sagar, can I get your question, because you have not. Okay, yeah. I got your question. Is there any software? Okay. So okay, so I think any doubts, like understanding what is HDFS and MapReduce, any kind of thing. Okay, if you have any questions, you can post me in my group. I'm continuing with my slides. So this is the Hadoop architecture. So let me explain you. Try to focus on the diagram. I'll go one by one. So client program is the client like me, you, any general people, and we are submitting some kind of jobs, which is going to take care by the job tracker. So here input file, if you see, there is a DFS, or you can say a data file system or input file. So this input file get splitted into number of chunks. As you can see, split 1, split 2, split 3, and all this. Then it goes to the mapper function, uh, where mapper will assign on what basis we need to split it, all this data. And after that, there are partition and combiner. Partition and combiner are the task of the reducers. As I already explained you, we are splitting first and then doing our individual task, and then combining our individual task into single unit. So all these things take care by the task tracker. And we have different regions over here. So because our data may be replicated to in any one of these region, and it is not like it's you who define it. May be by default also it gets replicated, or there is a also you can externally you can assign which region you want to store which data, or which region data. And there are two mappers, M2, M3. All these are mappers. As you can see, the task tracker combining all the data in the output file 1. So that is the output file 1 of a single reducer R1. Again, it is going to sort correct output. Sorting is basically done if you say, suppose your text is in any form, like in any kind of text, like Hadoop architecture. So H is the so Hadoop comes first, and A comes first, and then H come later. So sorting is mainly in a sorted manner. You sort it like alphabetically in ascending or descending order. It's up to you. Yeah, and in the reducer phase, after combining or after doing all their tasks, the TFS output file 1 and output file 2 will combine with each other, and they will sort their outputs, and write those data in a single output file. Okay, I got some questions. Can any OS platform be used while working with HDFS file system? Yes, yeah, yeah, obviously. This is not dependent on any OS. You can run it on Windows, Mac, Ubuntu, CentOS, anywhere else, because it is basically a the base. It is built upon the JVM, Java Virtual Machine. So as you know, Java Virtual Machine can be run in anywhere else. So yeah, so the same concept is for Hadoop as well. Like it is not OS specific and language specific. Okay. Okay, so if anyone have any doubts or any kind of questions, so they can they're open to post it on the group, WhatsApp group, and also let's catch up again after 5 minutes. Let's take 5 minutes of break, so that I can also be able to read all the questions and come ready with the solutions. Okay. Okay, so Vidyasri have asked, you check for some person on Facebook, and Hadoop system actually checks it for me, right? Like how you told about searching RAM in a chapter. First of all, Hadoop is not checking for some person on Facebook. Hadoop is basically dealing with the data, and the data that is coming. So I just told you like how Hadoop is useful for processing a huge file system or huge data in a very small period of time, like with the concept of called master and slave. So I told you like Ram is a chapter in the whole. In one chapter, Ram will be there present, and the chapter consists of 4 pages. So if each individual workers is going to read the whole data and process the data and give me the results, so it will taking me 30 minutes or 15 minutes, like that. But if I ask that my slaves to read only the first page, one slave will read only the first page, and it will find, say suppose Ram comes 2 times there, so its task is done, that slave is done, and it submits his result to me. The next person will again go to the second page of that chapter, and it find like okay, Ram coming here for 5 times, and it is submitting me the number of results. So how much time I get now till now up for from the 2 slaves? I get total count is 8, 3 from the first and 5 from the second. Like this, all the slaves will complete their task and send it to me, submit to me their output, and after all the output, I will just combine the output, and I'll get the result. So I can know, okay, Ram is repeated this many times in chapter 1. Any OS platform can be used, yes, because Hadoop is built on Java JVM. Since Java can be run at any platform, it is not platform independent. So Hadoop is also not platform independent because it is built upon Java on the top of the JVM. So no OS specification is here. Hadoop can run anywhere. So like in HDFS, it is said like write once and read anywhere. Same concept of JVM. Write once and use anywhere. So no, you can run it on Ubuntu, Windows, Mac, any OS. It's not specific to that. Badal Misra, words of Luna Sino has functions can be used as the data can't be sorted in any sense. It seems like dense indexing can be done, but it is on different machines. How do we know which part of data resides where? So this part is not your task, Badal. It's basically task of the job tracker, task tracker, and the secondary name node. These are the daemon processes which is keep running in the background, and they have the idea. That's what I told you, like master doesn't do anything, it only keeps the information of all the slaves, what slaves is doing what, and where it is keeping the data, where it is storing the data, how it is submitting the data, everything. So their master task is nothing but to supervise. So master data know which data is reside where, and you don't need to worry about this data resides where, because as I said, it is replicated in the 3 different places. So the UI or the Hadoop software, it is not going to tell you which regions, because the regions may be anywhere. In India region, might be Indian data, might be stored in American database, or American data base copy, maybe have a copy in India. Like when we are working in software companies and IT companies. So suppose if, for example, Facebook. So Facebook has an headquarter in US, UK, and say suppose tomorrow, and in India as well, obviously. So it's not like, and they have their data centers, or you can say their servers or machines all over the regions. So India, if India wants to store some data, that is not like he have to store the data in India only. He can also send that back up to American regions, but that should be connected to each other. If it is not connected to each other, your data will not be get stored on regions. So the data will be stored only in a network. If not network is there, then how it will find which data is coming from where, because obviously if I working in a combined network, then only I can know where my data is and whom to send and how to make it. All about networking. So all those part is taken care by the Hadoop framework. You don't need to worry about that. Your data will be secured. And these regions is you there have their own algorithm. On the basis of that algorithm, they split the data depending on their regions available, because all the regions might not be available. So if that region is not available, obviously they will going to replicate the data in different regions. Okay, so I think questions is done now. Most of the questions is done. Yeah, so now we'll come on application of big data. So nowadays application of big data is everywhere. You can't say big data is specific to big data application is specific to only IT companies or software guys or computer science people. It is useful for civil, mechanical, everywhere, because now the data start generating from every sources. And after some time, we have also as you all have would have heard the name of IoT, Internet of Things. So those are sensors data. So those are not computer science and everything. So those data will also become, and to process those data, and that also will come in a very huge number of speed, or huge number of size and speed. So obviously big data will we have to use big data there. Without big data, we can't handle those kind of data and process those data. So first application is the sentimental analysis. I will show you the way how sentimental analysis is done from end to end, from starting to the end. Second one is the recommendation engine. Third one is the healthcare and the agriculture. These are just numbers. Like, it's not only in these areas only application of big data. There are many areas, and I think we have some time limitation, so we can't discuss all those applications. But when you come to in this domain, you will get to know, and you will explore many regions where the big data is applicable. So nowadays, like most of the people are concentrating on the sentimental analysis, and sentimental analysis become a very good application of a big data, because it gives you what your viewers or what your audience think about it, whether they find it good or wrong. For example, I am doing this seminar now, and I need to know whether my seminar is successful or it is flop. People liked it or not liked it. What are their feedbacks, or what are their thinking? So how I can't ask in each of you, like there are you are so many people, so I can't keep asking each and everyone, did you like it, did you like it, did you like it. It will be a manual work, and it will take me lots of time. So what I'll do, I'll get the comments from this channel. I'll extract the text, and we have something called word mapping, where some positive words are present there, some negative words are present there, and some negative words are present there in our data set. Data set means, suppose if I say love, I love it, I enjoy it. So enjoy, love, joy, all these are like positive words, correct? And I don't like it, I don't give a fuck, something like that. So all these are negative terms. And neutral, like okay, some neutral, like they are not feeling good also, they are not feeling bad also. So how I will going to use Hadoop to get this data, or how to analyze the sentiment? So what I'll do, I have a text file now with all your comments. I splitted each words. I remove the stop words from here. The stop words is like a, the, me. All those things are which is getting repeated every time in English dictionaries, or you can say stop words are those which are not used because they are not giving any kind of sense. So we are removing those stop words, and we are more concise on the terms, like your positive terms or negative terms. and from there I am counting the number of positive terms and number of negative terms. So if I'm getting a count of positive terms more than negative terms, then I can say, okay, my seminar is not bad. I get a good feedback. People are liking it. But if my negative feedback, negative terms are more than positive terms, then I can say, yeah, people, I think they have not liked my seminar. And based on that, I will try to improve my presentation skills or something which, because of which my seminar or this webinar is not work for me. So what it will give me, I'm just taking as a very small example. You can think it as a very big, how much you can. For me, for individual, what is giving me, how Hadoop and big data is helping me, I get to know whether my audience are really liking it or not. And if it's not liking it, then why? What is the reason they are not liking it? And I will improve it. So nowadays, many business persons who are doing businesses, so suppose some Food Panda, you can take the example of Food Panda, Uber, Ola, all these are doing businesses in India. So Food Panda, if you don't like the food, you will give the review. I don't like the food. Food is yours. So they will come to know, okay, our food quality of this particular product is not good. So we need to concentrate on this, and so that the next time when they will deliver you the same food, you'll find it good. So it is like for them also, it is helping them to get to know whether your consumer or customer is happy with your food or not. So that in that way, in that sense, big data is helping Food Panda to expand its business, because he know the behavior of the consumer. So mainly sentimental analysis is nothing but the behavior of the customer, like how customer is behaving with you, like what is his feedback or his points, sentiments about your product. So nowadays, whenever anyone trying something new in startup, they actually focus on sentimental analysis. Tomorrow, if I want to open a restaurant in Guwahati, or say suppose in IT Silchar, and I start selling it, but if I don't know whether my customers which is coming and then leaving my restaurant and they are not coming back again, then what is the reason? So I could not able to solve that problem. So with the help of sentimental analysis, I can get to know my weaknesses, and I can try to improve on it. Second one is your recommendation engine. So do online shopping. I think nowadays people start watching Netflix, Prime Video, everything. So when you when you watch all these things, when you shop on Amazon, let me first give example for online shopping. So suppose Amazon or Flipkart. I've been noticed sometime, like when you are purchasing some product. So in the recommendation, they are telling you these are the recommended products for you. So how they know whether these are like recommended for you? Why? Because from your order history, they take the your information, like what you have purchases, and for that product they also see the other people, not your friend, anyone, other users who have bought the same product and also buy some other things along with that. So so there are people which are kind of same-minded people, or maybe not, but say suppose if you are same-minded people like me, I also want like that product, so they recommend me. It might be I am also interested in buying that stuff. So this is the way they are recommending people, because when you are purchasing a single and how they are expanding their business. So suppose if you are buying a Lumia mobile, so in the recommendation you see a Lumia cover is there, this warranty cover is there, all these things. So you see like other people are also buying those things, so why don't you? So you also along with your Lumia mobile, you will also buy the cover and all those screen guard and all. So like that, you are purchasing one thing, but because of this recommendation, you have also purchased some other products. So that is obviously going to increase their business. So this is for recommendation engine. Another is in your video prime. YouTube also, you can say YouTube is also a very good example of recommendation engine. When you watch some comedy kind of video, so it's in the sidebar it will show you some videos which is only comedy, like you can find this comedy thing only there, not like some serious sad or some kind of song. So whenever you are searching or typing for Daljit or Honey Singh song, then in the recommendation they are only giving you recommendation for Honey Singh only, and other videos which is also like those videos, like same kind of content. So this way YouTube is also using recommendation engine there. Third one is your healthcare. So basically nowadays healthcare become a very big industry in big data, because people are become very conscious about their health. And so how healthcare using big data. So when you're going for a clinic for a checkup and you are coming back, they don't give you any kind of database or some kind of report. They give you normally a report which is on paper. So next time when you visit for a doctor, so you need to carry your previous report with you, to so that the doctor has the knowledge like what a person's what person is going through earlier, and and depending on the past your past diseases, they give you some other recommendation like that. So although, but this is not possible because you can't keep story or all your checkup documents with you in paper. Like today, we don't you prefer documents or papers reports. So healthcare, or in healthcare, how it is helping? We are scanning. We are getting the data by scanning the. We have a scanner which will scan your report, and it will going to store the data in your database, so that when the user is going to for the second time to from the to visit some doctor, a report of your earlier diseases will be sent to that doctor immediately. Read it and get to know what's your problem and give a better solution, because doctor also need to know what's going on. Because if you are suffering from some fracture earlier and doctor did not know about it, then it will like do a fresh check and fresh medicine will be given to you, which may be the same medicine which your earlier doctor have given. So this way, like doctor also getting the insights of your body, of your diseases and all, and on the basis of that they are also giving you a better treatment. How it is helping big data in agriculture? So in agriculture, the farmers are producing lots of products, foods, and vegetables. So which vegetable is needed in the market, which is not? So like you have seen like sometimes onion prices goes so much higher, tomato price goes lots of higher. Because of the less production, it is not getting produced so much that it can satisfy the normal people needs. So with the help of the big data, you can get the insight like which vegetable is more consumed in which year and why and which season. So that is going to help farmers to concentrate on particular product. Say suppose tomato, if tomato is very much in demand in the month of January to March, then they will obviously try to produce more number of tomatoes in that period of time. If say suppose tomato is not needed in June or July, then if a farmer is producing those uh, tomatoes in their fields and it is not getting sold, then it is get wasted. So it is a loss of farmers as well. So in this way, big data is helping the agriculture sector as well. So any questions now on applications, like if you want to know like how big data is, it's not only all the listed terms here. If you want to know the application of big data in some other sector also, you can ask in the WhatsApp group. Is anyhow machine learning is connected to big data? Yeah, actually, without big data, you can't think of machine learning. We have a session tomorrow also on machine learning, so there I can give you. But right now I'm giving you a small basic introduction of machine learning. So machine learning is nothing but your past experiences from where you are getting the. You can make decisions. Like if earlier I got admitted to some XYZ institution for engineering, and I found it very bad and very bad. So if someone asks me, come to me and tell me like I'm getting a seat on this particular institution, shall I go or not? So how can I give him advice from my past experience? Because I have also done my BTech from there, and I didn't found it very good. It's very bad institute. So obviously I'm going to tell him, don't go. I have a past experience there. So try something else. So all these things are like how you think a machine can predict all these things. So unless and until you have a good data sets, like if you have a very good experience, good number of experiences, then only you can predict, or you can drive some decision. And this is called data driven decisions. Like your data is telling you what decision you should take. So if I'm considering only 2 or 3 cases, might be, for example, if I'm telling you, might be I found that institution bad, but maybe some person find it very good. Some other person may find it very, very, very good. So I can't say ki only based on my experience, based on only single user data, you take this decision. So they need a number of reviews. For example, forget about machine learning. Tell me, whenever you buy some product from Amazon or Flipkart, first thing you do is go to the reviews and check what people are telling about this product. And based on that, if you see the rating is very low, then you come to know that the most of the audiences or most of the people or users are telling no, means it is not good. But if someone is telling, if you go and see someone having 4 rating out of 5, so there you also see some rating which is giving very bad feedbacks. But compared to that, most of the people like the product. So you are going with the positive feedbacks. If most people are going to vote for this product, so you are also going, because on the basis of the few number of data, you can't take the decision. So machine learning is obviously connected with big data, and there also a lots of processing is needed, because your machines is going to predict you tell you everything. So obviously your machines need to be very robust, and your data collection data will be very huge. I told you, like if your data is getting very huge, it's coming from different kinds of sources, then you need a big data. So you can say big data is the base on which machine learning is now operating. So it's all a stack, one upon another, it's keeping. On JVM, Hadoop is built on Hadoop, Spark is built on Spark, and all these ecosystem machine learning is taking the help of that, because those systems are generating and processing your data efficient manner. So yeah, artificial intelligence as well. Nowadays, IoT, artificial intelligence, big data, all these things are like a kind of a same group, okay, where you need at some point you need help of from each of these components. Without a very good data set, without a very huge data, you can't predict a very good product. If I need to predict whether a person um, from cancer or not, how can I predict? I'll have to get the all the data of all living people having cancer in the world, and need to analyze what kind of people having what is the reason they are suffering from cancer. So I need to find the patterns from the data. Is this much year old, and he's smoking or he's doing this kind of thing, that's why he suffered from cancer. So I can predict that the person which is from age of 30 to 40 don't smoke, otherwise happen to you also. So machine learning is nothing but another subset, you can say. It's a very huge field. If you think if you relate each and everything, you find each and everything is connected to each other, internally, directly, indirectly, but they are all connected because we are living in a connected world. Facebook is a good example. Their data is like so huge that what do you say, that on the basis of their data we are predicting people whom you need to, because from the data from what user is doing, from their behavior they are finding the other people which is also kind of same kind of people, like what they are liking. So same kind of people, and they are bringing all those people in a same single platform by connecting them. So all these machine learning, big data, artificial intelligence, all these three technologies are the very big technologies today. And later on, IoT will also join this what say, um, join this group, big data, because for IoT data also we need big data, because sensors data coming at a very high rate, irrespective of what social media platforms are generating. So everything is interconnected to each other. Okay. Any other questions? So also so this is about big data. I don't want to give a huge lecture on big data because I don't know whether you people know about big data. Maybe most of you know about it. Most of you didn't have any idea. They are the beginners. And if I keep giving you, then you will not understand, because you will be lost. And that's what I told. If there are huge number of slides there, you will be lost to what I told in the first slide. So I don't want to make it big. I just want to give you a very basic introduction of big data, what it is actually, and how a beginner without any background. Today, you don't need any background of computer science, because nowadays information technology come in such a stage where you can learn anything, and it's not like you need to have some background. Any beginners can start it. It's nothing tough there. Just you need your dedications, your passion about learning big data, and your efforts. That's it. Yeah, so this is the solution architect on sentimental analysis, what I told you. So this is the digital users, which is the Twitter website. And to get the data from Twitter, you need to go to developer page of Twitter and create your account there, and get some token so that it can authenticate you to fetch the data from the Twitter. And forget about all this Flume agent and all these are terms. Flume agent actually is a data collector which is collecting data from your source, and after Flume agent it is passing to our HDFS, or you can say Hadoop, where it get processed, map reduce happens, and after map reduce, so whatever you want to see, like suppose you want to see which is a trending hashtag there, you can apply your own logic how to which is the trending hashtag. If you want to know people's sentiment on particular topic, you can get that as well. So, and all these things you can do using Hadoop. Now Hadoop also becoming old. Now Spark has taken over the Hadoop, mainly MapReduce. I am telling you, MapReduce become very difficult for programmers to program because it's earlier it was on Java only, and writing a huge number of codes for MapReduce, it's a big for programmer, because if programmer don't write program faster, then obviously his processing will get slower. So how Spark is okay, now I'll tell you some of the softwares which is helpful for doing all this MapReduce tasks. Like if you don't want to write MapReduce, so you can use Hive. So Hive actually invented in Facebook, because Facebook want to use want to do some SQL queries, but since MapReduce is different terminology, so they have built one software called Hive. It's not a software; it's also kind of a framework which is give you the flavor of SQL, because most of us know SQL from the beginning. So if I ask you to program SQL, then you will be like very easily you can write queries. But if I ask you to do a program in NoSQL, you even don't know what is NoSQL is. So Facebook has created Hive, which is converting your MapReduce output into a SQL query, where you can just write a SQL query, and that SQL query will actually it's actually converted into MapReduce internally. Like your data SQL query will become MapReduce internally, and get the result from MapReduce, and your output will be there. So if you don't want to write a MapReduce program in Java, you just you can use Hive, and it is also built on top of Hadoop. Another one is called Pig. Pig is founded in Yahoo, which is also a kind of a script, because we don't want to write a 10,000 lines of code or 1,000 lines of code. So it's a normal script which is also internally converting the that script is converting the data, loading the data on your database, doing the MapReduce internally, and getting the results normally in a single 4 or 5 lines of scripts. So that is how they have customized this MapReduce. Why Spark come into picture? Because since Hadoop have only hard drive or file system, so we also know like RAM is faster than your hard disk. So Spark has done nothing. Spark has not his own storage system. They are using HDFS storage file for storage, and they are processing the data not on the hard disk but on the RAM. So that is why it becomes much faster than MapReduce, or you can say old version of Hadoop ecosystem. So that is why people are preferring now Spark, because it is processing your data on your RAM, not on your hard disk. It is store the data on hard disk, pick up the data from the hard disk, and start processing it. Okay, so all these are the terms which you'll find. There are so many invention is going on every day. New softwares are coming in big data domain. So once you start from the basic, you will come to know, and once your base is strong, you the other things is just like a bricks which you just need to build your building. That's it. Okay, so installation of Hadoop on your local. I will not going to help anyone on this, because this is the first thing you should try by yourself, unless and until you fail more than 3 times. If you fail for the first time and you give up, then you never learn big data, never learn Hadoop. So if you want to really learn Hadoop and see, so the best way is to do by yourself. So go and these are the prerequisites which you need to download while installing Hadoop. So first of all, your system should have Java, because without Java, Hadoop cannot run. Download the Hadoop jar from official website and extract it on your folder. And this is the command in your Hadoop folder. Go to the Hadoop folder, then go to your bin folder, and this is the command which you have to give to start all your services. And when all the services is up, then you go to your local host 50070 port, and if you see such kind of UI on your screen, then yeah, you are done. You are successfully installed with Hadoop, and you can explore the things. So coming in our next session, mainly on writing programs using Hadoop and installation and all, because today if I give any kind of demo, then it will be like a bouncer from your head, so you will not be able to pick up these things easily. So if anyone have a basic knowledge and they want to start it now, they can ping me on my on our WhatsApp group if they need any kind of help, if they are stuck in somewhere, if they tried and they find some kind of issues, then I'll be here to give you a solution how to install Hadoop and how to start working with Hadoop. Yeah. So all this is about big data, a basic introduction today. Tomorrow we have a session on machine learning, which is basically deal with all kinds of algorithms, classification, regression, how machine learning come into existence, how it is very useful nowadays. All those things we'll discussing tomorrow. Any doubts? Any questions? So I'm stopping now the session. Thank you for attending the session. I hope you like it. If you don't like it, maybe because I have no past experience on giving such webinars. So I have given, but maybe this is the first time I'm doing live. So if you have any kind of suggestions or any kind of complaints, please send us so that we can improve later, and we will give a very good presentation next time or seminar. Thank you, guys. Have a good day.